China just landed a rocket booster for the first time in history, and they did it with a net. Starship Flight 13 is on the pad, 33 Raptor engines, the most powerful rocket ever built, and the most critical test yet for the future of the Moon and Mars. The James Webb telescope found the faintest planet ever seen from Earth. And Euclid just discovered the oldest quasars in the universe, light that has been traveling for 13 billion years to reach us. All of that, plus missing black holes found, new horizons waking up 6 billion miles away, a space debris crisis getting worse by the week, and what's in your sky this July. This is This Week in Deep Space Digest. On July 10, 2026, China did something that only one country had ever done before. They landed an orbital rocket booster. And they did it in a way nobody had seen before. The Long March 10B lifted off at 12:15 in the afternoon local time from the Hainan International Commercial Aerospace Launch Center in Wencheng. It deployed its payload, a satellite called CX-26, successfully into orbit. And then, about 6 minutes after stage separation, the first stage did something remarkable. The Long March 10B is China's answer to the Falcon 9. It stands between 63 and 70 meters tall with a 5-meter core diameter and a liftoff mass of 760 tons. The first stage is powered by 7 YF-100K engines burning liquid oxygen and kerosene, producing around 890 tons of thrust. In its reusable configuration, it can carry at least 16 metric tons to low Earth orbit, putting it squarely in the same performance class as the Falcon 9 that SpaceX has been flying routinely since 2015. Here's where China's approach diverges from everyone else. SpaceX lands its Falcon 9 boosters on deployable legs, either on drone ships at sea or concrete pads on land. Blue Origin does the same with New Glenn. China went in a completely different direction. The Long March 10B booster descended toward the South China Sea, and instead of landing on legs, it used attached landing hooks to latch onto a cross-shaped, high-strength arresting net suspended over an offshore recovery vessel called the Linghangzhe, which translates to navigator. The ship is 144 meters long, 50 meters wide, and displaces 25,000 tons. The booster came in using LiDAR tracking for precision guidance. As it made contact with the net, rail-mounted dollies repositioned automatically, and pulley-driven tension cables absorbed the kinetic energy, leaving the smoldering booster suspended in midair above the deck, not sitting on legs, hanging in a net over the ocean, intact. This wasn't an aesthetic choice. Chinese engineers chose the net system because it eliminates the need for heavy landing legs and hydraulic systems entirely. Those components add mass to the booster, mass that otherwise could be payload. Removing them directly improves the rocket's economics. The net also offers a wider capture window, making the system more tolerant of slight landing point deviations than a precision leg touchdown on a pad. Let's be clear about what happened here. SpaceX first landed a Falcon 9 booster in December 2015. Blue Origin recovered New Glenn in November 2025. China just joined that club. And unlike Blue Origin's New Glenn, which had already flown multiple times before this milestone, the Long March 10B did this on its maiden flight. This success also comes after two very public failures in December 2025, when both Landspace's Zhuke-3 and KSA's Long March 12A crashed during attempted leg-based landings in the Gobi Desert. The decision to switch to a net system paid off on the first attempt. But the deeper strategic context is what makes this landing significant beyond just the engineering. The Long March 10 family is central to China's plan to land taikonauts on the Moon by 2030. A direct challenge to NASA's Artemis program and the race to establish a permanent presence at the lunar South Pole. Reusable rockets dramatically lower the cost per kilogram to orbit, and China needs that economic advantage to build the Guowang megaconstellation, roughly 13,000 satellites designed to rival Starlink globally. Following the landing, shares in Chinese aerospace companies surged 10%, the maximum daily limit allowed on Chinese exchanges. KSC has already announced plans to refly this exact booster before the end of 2026. The era of reusable rockets is no longer just an American story. On July 17th, Starship Flight 13 was on the pad, fueled up and counting down. And then, it didn't launch. During the final moments of the countdown, some of the 33 Raptor 3 engines failed to start, triggering an automatic launch abort. The vehicle safed itself exactly as designed, and SpaceX immediately began offloading propellant. No damage, no explosion, just a rocket that decided today wasn't the day. Elon Musk posted the update on X within minutes of the abort, first confirming the engine's start failure and the automatic abort, then, about an hour later, a second update with the path forward. To be confident of a good flight, 2 Raptors will be removed and replaced. Most probable launch timing, in his words, is early next week. And it's worth understanding why an automatic abort on the pad is actually the system working correctly. Starship uses an autonomous ignition monitoring system. If any engine in the startup sequence fails to reach nominal conditions within the required window, the flight computer aborts automatically. No human has to make that call. The vehicle decides. A few hundred milliseconds of bad data, and the whole countdown stops. That's not a failure. That's exactly the safety architecture behaving as intended. The decision to replace 2 Raptors rather than just attempt a recount is also significant. SpaceX could theoretically try again with the same engines after diagnosing the startup issue. Choosing instead to swap them out tells you they found something specific they didn't like, and they'd rather take the extra days to do it right than risk a repeat abort or worse, an anomaly during flight. A brief recap of what's at stake for when Flight 13 does fly. This is the second test of the Starship version 3 hardware, 408 feet tall, 33 Raptor 3 engines, over 18 million pounds of thrust. It carries 20 functional Starlink V3 satellites, the first real payload ever flown on Starship, and it must attempt the in-space Raptor engine relight test that Flight 12 failed to complete, the single most critical capability SpaceX needs before NASA's Artemis 4 the moon landing can proceed. The abort doesn't change any of that. It just means we're watching early next week instead of today. We'll cover the result in our next episode. About 63 light-years away from Earth, there's a young star called Beta Pictoris. It's only 20 million years old, barely a teenager compared to our 4.5 billion-year-old solar system. And this week, astronomers confirmed a third planet hiding in its system, one that's been sitting undetected in archival telescope data for 11 years. The planet, designated Beta Pictoris d, is roughly 2.4 times the mass of Jupiter, orbiting at about the same distance from its star as Neptune orbits our Sun. It takes 91 years to complete a single orbit. It is the faintest exoplanet ever directly imaged from Earth, 100 times fainter than the other giant planets in the same system. Its surface temperature is around 330 degrees Celsius. Here's the part that makes this discovery genuinely remarkable. 2 completely independent teams found this planet just 5 days apart, without knowing about each other. A team at the University of California spotted it first using the James Webb Space Telescope. 5 days later, a European team at the University of Edinburgh confirmed it using the Very Large Telescope in Chile. Both were actually trying to study Beta Pictoris b, a planet already known to be in the system, when they noticed something else in the frame. Once they knew what they were looking for, they went back through archival data and found the planet had been captured in telescope images dating all the way back to 2014. 11 years of data, hiding in plain sight, lost in the glare of its star, and dismissed as background noise. Webb's contribution here goes beyond just seeing the planet. Using the near-infrared spectrograph instrument, the telescope didn't just detect light from Beta Pictoris d, it read its atmosphere. The telescope picked up a distinctive barcode of carbon monoxide absorption lines alongside water vapor and methane detected by the mid-infrared instrument. This spectroscopic fingerprint not only revealed the planet's atmospheric composition, but also its radial velocity, confirming its orbital motion without ever needing to see it as a bright point of light in the traditional sense. Beta Pictoris is now only the second planetary system where more than 2 planets have been directly imaged. It joins HR 8799 as one of the rarest objects in observational astronomy, a multi-planet system we can actually see rather than just infer. More importantly, this discovery proves that astronomers can find hidden worlds through chemical signatures rather than relying on capturing a visual point of light. In a universe where most planets are invisible to us, the ability to detect atmospheric chemistry as the primary discovery method is a fundamental step forward. The next generation of observatories, particularly the extremely large telescope currently under construction in Chile, may be able to apply this technique to smaller, potentially rocky planets. While Webb has been making headlines for years, another space telescope has been quietly doing something extraordinary. The European Space Agency's Euclid telescope, launched in July 2023, just published a discovery that has broken two cosmic records simultaneously. Euclid found 31 previously unknown ancient quasars from the very early universe. Two of them are now the oldest and most distant ever observed. Their light has been traveling for over 13 billion years to reach us. These quasars existed when the universe was approximately 670 million years old. That's just 5% of the universe's current age. For context, a quasar is an active galactic nucleus, the superheated accretion disk surrounding a supermassive black hole that is actively consuming enormous amounts of material. As the black hole feeds, the friction and gravitational forces heat the surrounding gas to millions of degrees, releasing more energy than entire galaxies. These two record-breaking quasars were already shining with the light of roughly 1 trillion suns when the universe was barely getting started. The existence of these objects intensifies one of the greatest unsolved problems in astrophysics. How did supermassive black holes grow to billions of solar masses when the universe was only a few hundred million years old? Standard models cannot fully explain it, and as one of the Discovery team's co-authors put it, every step further back in time makes the puzzle more perplexing. What makes this Euclid discovery particularly powerful isn't just the two records. It's the 12 quasars with a redshift of 7 or higher that were found in total, which more than doubles the entire previously known population of quasars from this era. Before this, it had taken astronomers more than a decade to find a handful of quasars this distant. Euclid found 12 of them in a single survey. And crucially, these aren't just the brightest, most extreme outliers. They include fainter, ordinary quasars, giving scientists the first genuine statistical census of this period, rather than just a collection of anomalies. The Euclid-wide survey will eventually cover more than a third of the entire sky. Researchers are already targeting the first quasar beyond a redshift of 8, which would reveal a supermassive black hole in the universe's first 630 million years. James Webb follow-up observations have already been approved to measure the exact masses of these newly found black holes. Here's a cosmic detective story that took over 2 decades to solve. Omega Centauri is a globular star cluster about 18,000 light-years away, containing roughly 10 million stars. It's so massive that astronomers suspect it's actually the remnant core of a dwarf galaxy that the Milky Way cannibalized billions of years ago. Models have long predicted that a cluster this massive should contain around 10,000 stellar mass black holes, the compact remnants left behind when massive stars explode as supernovae. Despite decades of searching, none had ever been directly confirmed. Until now. They didn't find it by detecting X-rays or radio waves, which is the traditional approach. Instead, they used astrometry, measuring the tiny positional wobble of a visible star that is being gravitationally tugged by something invisible. By analyzing over 20 years of archival Hubble Space Telescope data from 2002 to 2023 and enhancing it with precise near-infrared measurements from James Webb, they tracked a star moving in a telltale wobble around an unseen massive companion. The visible companion star is 0.78 times the mass of our Sun. The invisible object pulling it around weighs 4.46 solar masses. That's too heavy to be a neutron star, which maxes out at around 2.5 solar masses. It's a black hole, and it takes the companion star 94 years to complete a single orbit around it, making this the longest period black hole binary system ever discovered. Interestingly, this black hole sits in a mass range called the mass gap between 2.5 and 5 solar masses, where black holes are rarely detected in gravitational wave observations. Finding one here fills in a gap in our understanding of how massive stars collapse. If there's one, there are almost certainly thousands more. The search for the other 9,999 has just gotten a whole lot more interesting. Here's a number that stopped space sustainability experts in their tracks. Between June 2025 and May 2026, Starlink satellites performed over 355,000 collision avoidance maneuvers. That's more than 3 times the number performed in all of 2024. To put that in individual terms, each Starlink satellite is now being forced to dodge debris or other spacecraft roughly once a week. The constellation has grown from about 6,000 satellites in 2024 to over 10,000 as of June 2026, and the total number of operational spacecraft in orbit has jumped from 10,000 to approximately 16,000 in just 5 years. SpaceX has applied to the FCC to expand Starlink to 100,000 satellites. Experts predict that by 2030, the constellation could be making over 1 million avoidance maneuvers every single year. Professor Hugh Lewis at the University of Birmingham has stated plainly that a collision involving an operational satellite in the Starlink constellation is, in his view, not a question of if, but when. The problem isn't just SpaceX. Amazon LEO is deploying. China's Thousand Sails constellation is targeting the same orbital shells. Several companies have proposed space-based data centers in LEO. The maneuver count will only accelerate. Experts are now calling for regulators to require companies to disclose predicted maneuver counts before launch approvals are granted, essentially forcing them to prove their satellites can safely coexist before they get permission to add more. Before we wrap up, this week has some genuinely good reasons to go outside and look up. 3 specific things to put on your calendar. On the morning of July 22nd, before sunrise, look east and find Mars glowing with its characteristic orange-red tint. This particular morning, Mars will be sitting almost exactly at the midpoint between 2 of Taurus's brightest stars, Aldebaran to its lower right and Elnath to its upper right, forming a nearly perfect straight line across the sky. What makes this visually interesting is the color. Mars and Aldebaran share almost the same orange-red hue, sometimes called the rival of Mars in ancient astronomy for exactly this reason. Seeing them framed together with Elnath's cooler white light in between is one of those alignments that looks better in person than any photo can capture. No telescope needed, just a clear view of the eastern horizon about an hour before sunrise. 2 nights later, on July 24th, the waxing gibbous moon, 82% illuminated, will sit just 2.8 degrees away from Antares, the blazing heart of Scorpius. Antares is one of the largest stars visible to the naked eye, a red supergiant so enormous that if it replaced our Sun, it would swallow everything out to the orbit of Mars. And if you're up late this week, the southern Delta Aquariids are already active and building toward their peak on July 29th to 31st. Under dark skies, you can expect 15 to 25 meteors per hour at peak, steady, graceful, medium-speed streaks radiating from near the constellation Aquarius. And if you can wait 2 more weeks, August 12th and 13th bring the Perseids, the best meteor shower of the year, with 50 to 100 meteors per hour. This year the moon is new at peak, meaning the sky will be as dark as it gets. Mark your calendar now. We'll be back next week. If this was useful, you know what to do.